Hello everyone, this is Miss Chelsea, and today I will be introducing systems of equations. There are a few terms we need to know. First of all, a system of equations is a collection of two or more equations with the same variables. A solution to a system of equations is the coordinate pair that is a solution for all equations in the system. It is written as a point, aka open parentheses x, y, close parentheses format. We also need to remember the slope-intercept form of an equation, y equals mx plus b, where m is the slope and b is the y-intercept, as well as the standard form of an equation, ax plus by equals c, where a, b, and c are all integers and a is positive. Next, let's try identifying systems of equations. We are going to circle the items that qualify as a system of equations. Item 1, y equals 6x and y equals 2x plus 3 is a system of equations. Item 2, y equals 4x, is not a system. It is just a normal equation. Item 3, y equals 1/2 x and x equals 9, is a system of equations. Item 4, 3x plus y equals 9 and y equals 7x, is also a system of equations. Item 5, 3x plus y equals 9 and a equals b minus 7, is not a system of equations because the variables are different. Item 6, a equals 9b minus 1 and a plus b equals 0 is a system of equations. Item 7, a plus b plus c equals 2, a equals 7b, and b equals c minus 7 is a system. And item 8, x plus y equals 9 and x minus y equals 1 is also a system of equations. Notice how a system of equations always has two or more equations. All equations in a system must have the same variables regardless of what they are. Next, let's try to develop a better understanding of the solution to a system of equations. Finding the solution to a system of equations means finding the pair of variables that work for all equations at the same time. Let's do a quick review of some linear equations. First of all, we want to find 4 solutions to each function below and use the inputs given. So, if we look at y equals 2x and we plug in 0 for x, we will get 0 for y because 2 times 0 is 0. Plugging in 1 for x, 2 times 1 is 2, so we get 2 for y. Plugging in 2 for x, we get 2 times 2 is 4, so we get 4 for y. Plugging in 3 for x, 2 times 3 is 6, so we write 6 for y. Let's do something similar for the second equation. Negative 2 times 0 plus 4 is 4. Negative 2 times 1 plus 4 is 2. Negative 2 times 2 plus 4 is 0. And negative 2 times 3 plus 4 is negative 2. Now for step 2, let's circle the coordinate pair that the two tables have in common. This pair will be a solution for both equations. Well, the point 1, 2 is in both equation tables, so we're going to circle that. Next, let's discuss, do you think there will be another coordinate pair that these equations have in common if the tables were extended? Why or why not? If you look at the two tables, you'll notice that as x increases on the left side, y is increasing as well, but on the right side, y is decreasing. That means that y is going to keep getting bigger for the left side and smaller for the right side, therefore they will never cross again. Finally, the solution to the system of equations y equals 2x and y equals negative 2x plus 4 is the point 1, 2. In the next part, we will identify and test solutions to a system of equations. Let's look at example 1. Test a solution by substituting the x, y values of the coordinate pair into both equations for x and y. So we want to know which of the following coordinates is a solution to the system of equations below. Y equals 3x minus 10 and y equals 5x. If we were to try plugging in x equals 0 and y equals negative 10 into the bottom equation, y equals 5 times x, we would get negative 10 is equal to 5 times 0. And since 5 times 0 is 0, this is not true, so the answer cannot be A. The answer also cannot be B because when we plug into the bottom equation, we get 5 equals 5 times 0, and 5 times 0 is 0. Since this is false, then B cannot be a correct answer. Once again, let's try with C, and we get negative 4 is equal to 5 times 2. Since 5 times 2 is 10, this is also false. The answer has to be D, but let's check. Negative 25 is equal to 5 times negative 5, and negative 5 times 5 is just negative 25, which gives us a true statement. For the top equation, we would say negative 25 is equal to 3 times 5 minus 10. Now, 3 times negative 5 is negative 15, minus 10 is negative 25, and since both sides are the same, this statement is also true. When both equations are true, you have a solution, so D is our solution. Next, I want you to pause the video and try the practice problems below. You should have gotten B for number 2, D for number 3, A for number 4, and C for number 5. Let's try another example. Sometimes there are simple cases where a solution can be determined just by comparing the equations. Be on the lookout for systems of equations with the same y-intercept. If the y-intercepts are the same in both equations, that coordinate will be the solution to the system of equations. So in 6, the solution is 0, 0 because the y-intercept to y equals 1/3 x is 0, and the y-intercept in y equals negative 4x is also 0. In number 7, we have y equals negative 3x minus 6 and y equals x minus 6. Notice how both have the y-intercept of negative 6, which corresponds to point 0, negative 6, our solution. Also be on the lookout for systems of equations with the same slope. If the slope is the same in both equations, but they have different y-intercepts, there will be no possible solution. In number 8, there is no solution because y equals 4x plus 1 and y equals 4x plus 2 both have a slope of 4, but their y-intercepts are different. Now, why is this true? Well, try inputting the same x value into both equations. They will both be multiplied by 4 and be equivalent still. However, the first equation will add 1 while the second equation adds 2, making them no longer equal. The third thing you should be on the lookout for is when you have the same everything. If the equations have the same slope and y-intercept, it will have infinite solutions. So number 9 has infinite solutions because y equals 1/3 x minus 2 is written twice. They're the exact same equation. Why is this true? Well, since the equations are identical, they will have all the coordinate solutions in common. This does not mean any coordinate is a solution, just that they have all the solutions in common, which means if a point is a solution to one equation, it will be the solution to the other equation. Next, I want you to look at the following practice problems. Find the solution to each system of equations by comparing the equations. Pause and try these problems. You should have gotten no solution for number 10, the point 0.08 for number 11, infinite solutions for number 12, infinite solutions for number 13, no solution for number 14, and the point 0.00 as the solution for number 15. Now, let's practice identifying solutions to a graphed system of equations by doing example 3. If a system of equations is graphed on a coordinate plane, you can find the solution quickly by identifying where the two lines intersect. This coordinate of intersection, the only point they have in common, is the solution to the system. So, what is the solution to the system of equations that has been graphed on the coordinate plane to the right? Y equals 1/2 x plus 1 and y equals 3x minus 4. Notice how the two lines intersect at this point here, 2, 2. Well, that is our solution. Next, I want you to pause the video and try the practice problems. Find the solution to each graph system of equation for numbers 21 through 22. Choose the best estimate of the solution. You should have gotten the point 33 for number 17, 0, negative 2 for 18, 1, 1 for 19, no solution for number 20, A as the estimated solution for number 21, and C as the estimated solution for number 22. Finally, I want you to pause the video and try solving systems of equations by graphing. This means that you will need to graph each system of equations first, then find their solution or where the lines cross. For number 23, you should have gotten the point negative 3, negative 7. Number 24 has a solution 0, 0. Number 25 has a solution 4, 5. Number 26 has no solution. Number 27 has the solution 1, 1, and number 28 has the solution 4, 1. Make sure you've checked all of your answers and you asked your teacher if you have any questions.